Okay, now let's look at um, how to work or how to do certain operations on radical expressions. Now, the four basic operations obviously are addition, subtraction, multiplication, division. First, we are going to focus on multiplication. We have this product rule, which is basically the exponential law, a to the power ab to the power b in ab to the power n applied in reverse. It says the nth root of a times the nth root of b equals the nth root of a times b. Let's look at some example. This is square root of 3 and square root of 7. So it's square root of 3 times 7, which is square root of 21. This is square root of x plus 7 times x minus 7, which is square root of x squared minus 49. Now these are both 8th roots, so we can combine them. 10x times 8 times x to the 4, which is 8th root of 10 times 8 is 80. X times x to the 4 is x to the 5. Now some radical expressions can be simplified by factoring. For example, I can factor, if I look at this, 300 is 3 times 100, which becomes root 3 times square root of 100, and square root of 100 is 10, so this becomes 10 root 3. Similarly, 75 is 3 times 25, which becomes root 3 times root 25, which becomes 5 root 3. Cube root. This is cube root of 2 times 27, which is cube root of 2 times cube root of 27. Cube root of 27 is 3, so it's 3 cube root of 2. Fifth root of 64. So recall, 2 to the power 5 is 32. Right? So this is 2 to the power, or 2 multiplied by 32. So it's fifth root of 2 times the fifth root of 32, which is 2 times fifth root of 2. Okay, now here I have 500 can be written as 5 times 100 times x times y squared. Now that's square root of 5, square root of 100, square root of x, and square root of y squared. That's a 10, y, and a root 5x. Now let's look at adding and subtracting radical expression. The two tools used here are combining or factoring like terms. 7x plus 6x, you can just add these numbers and you get 13x. Similarly, 7 root 11 plus 6 root 11 just becomes 13 root 11, because the root 11 is common to both. And the second method is simplifying radicals, what we did just now. We recall that 18 can be written as 2 times 9, and 8 can be written as 2 times 4. So that becomes 7 square root 2 square root 9 plus 5 square root 2 square root 4. The square root 9 is 3. 3 times 7 is 21 root 2. Square root 4 is 2. So that's 10. So this actually can combine to form one single term, which is 31 times square root of 2. Here are some examples. We have two expressions here with fourth roots. One is 7, one is 2. So this becomes 5 times the fourth root of 3x plus 2 cube root of 3x. Now these are not like terms, so they cannot be combined. Cube root of 16, this is cube root of 2 times 8 minus 4 cube root of 2 times 27. This becomes 2 cube root of 2 cube root of 8 minus 4 cube root of 2 cube root of 27. And cube root of 8 is 2, so this is 4 cube root of 2 minus cube root of 27 is 3. 12 cube root of 2, which gives me negative 8 cube root of 2. Here we can use our properties. This is x squared y to the 1/3 plus, I can write this is 3 cubed, but I also have an x cubed, a y cubed, and an x squared y in the cube root. Right, so this is 5. Let's put this back in radical form, plus cube root of all of this, 3 cubed x cubed y cubed times the cube root of x squared y. Now there's 3 copies of each, so this is 3xy cube root of x squared y plus 5 cube root of x squared y. Now this is a like term. It's the same radical. So if I factor it out, I get 5 plus 3xy cube root of x squared y. A dividing rational expression, the tool is again the exponent law as follows. If you have nth root of a over b, you can distribute them. For example, this becomes cube root of 16 over cube root of 27. We've seen this is cube root of 2 cube root of 2 divided by 3 cube root of 2, which cancels out, so it's actually 2/3. And this becomes 7 4th root of 7 times y to the 4 times y 4th root divided by 4th root of x to the 14. That's y 4th root of 7y over x cubed. Now I can combine this and leave the 1/2, and this becomes square root of 45 xy over 5, which goes 9 times, which becomes 3 square root of xy over 2. Since these are again the same, I can combine them as one single radical. 48x to the 7y over 6x to the negative y. Now this negative y, I can deal with it right away by changing it to y squared in the top, because it's a reciprocal. X goes into this, x to the 6, and this goes 8. So this is cube root of 8, cube root of x to the 6, and cube root of y cubed, which becomes 2x squared y. An application example, find the perimeter of this triangle. Perimeter of any shape is the length of the boundary. The boundary here are these 3 sides. So the perimeter is 45 square root 45, plus root 80 plus root 125. Now this is 5 times 9. This is it's 16 times 5, and this is 25 times 5. So this is root 5, root 9, root 5, root 16, root 5, root 25. So this is 3 root 5 plus 4 root 5 plus 5 root 5, which comes out to 12 root 5. And you gotta put the unit. It's meters. Okay, that's it for this week's videos.